Okay, hi everyone. So this problem is super important to me to figure out, to see if you can prove that these things are in fact circles. Obviously they are circles experimentally, and so I just want to say that this is how math research is in my experience. I can only speak for myself, but how does math research feel like? Well, in my experience, there's first experiments. You either do it by hand or you get a computer to help you, and I've done both, and they're both good. But you do these experiments just to try to figure out what's going on in a certain situation that you're interested in. And the outcome of the experiment is something experiments reveal surprising pattern. That's the first thing that happens. The second thing. Well, first, here's the surprising pattern. If we take a vertical line, it becomes a circle. That is surprising. Okay? And then the second part is, can we prove? Can we prove that it always happens? That it always happens? That whatever that surprising pattern it was, can we prove that it always happens? Or can we find where it breaks? That's just as interesting. Find where it breaks. In other words, a counterexample. And if you succeed at either of these, this goes into a research paper. Okay? And that's how math research always works for me. There's always the experiments first, revealing something surprising. Only once you have that, then you try to prove, will it always happen? Or does it break? And the key here is, how will you prove it? Well, look to your experiments. When we look at here, we see that, for example, this orange line has that real part 1/2. Maybe if we called this A and B, the real and imaginary parts of the input, then this would be A equals 1/2 is this orange line. And somehow it became a circle with center at 1. Well, 1, 0. Okay, that is one fact. We have to figure out, in terms of A, what is the center? Well, let's look at this blue line was at 1.5. 1.5. A equals 1.5 is the blue vertical line. And weirdly, now the center is over here at -1, 0. So there's some way that the number A becomes the center of a circle. And then once we have a center, we have to ask, well, if this is the center of a circle, the circle is all the points here, what equation do they satisfy? Or, what constitutes a circle? What defines a circle with given center? Can we use that, whatever it is, to prove that every single, even the ones we didn't draw, all these vertical lines become circles of various sizes and centers, and that's what you need to do. And this is a hard problem, but you can definitely figure it out. It'll take a lot of time and a lot of trial and error and a lot of guess and check. And probably you'll need to, work for 30 minutes and then take a break, because in 30 minutes you'll have discovered nothing. So take a break, walk, get a snack. Your mind is working on it in its subconscious. Then do another 30 minutes. And then just repeat. And, it can be frustrating 30 minutes because you won't necessarily get the answer. You might just become more confused. But that is what math research is about. It's about being confused equals being confused, but stubbornly refusing to quit. Stubbornly refusing to quit, although you can take breaks. Okay, but breaks allowed. Breaks are allowed. Okay, good luck. Try to figure out the circles thing.